Greetings one and all once again. It's Mr. Bailey here trying to talk you through to understand better Paper 2 Edexcel's higher tier maths exam from November 2021. So it's a calculator paper, the first of the two calculator papers. So I'll talk you through some questions with more than one method, but if I'm not mentioning a method you're comfortable with, don't assume yours is wrong. Ask me or ask your teacher if you are unsure in any way, shape or form. So let's start off first of all by having a look at question number 1 together. Question number 1, we have to write down the inequalities shown on this number line. So we've got a hollow circle above -1 and the arrow is pointing to the larger direction. So this means x has to be bigger than -1. It can't be equal to -1. If it were, this circle would be filled in, but because it's hollow, that means x cannot include -1, but must be strictly bigger than it. So the answer to the first one is simply x must be bigger than the value -1. Part B. On the number line, we need to show the inequality that y is somewhere in between -3 and 4. So this time what we do is we draw circles above the values -3 and 4. We have a hollow circle at 4 because y must be lower than that value, so it can't be included within it. But at -3, because y is allowed to be equal to -3, hence this extra line underneath this inequality symbol, we put a filled in circle above the number -3. So we should have something that looks like this. Filled in circle above -3, hollow circle above 4, and a straight line connecting the two. Question 2, we've got a question about highest common factors and lowest common multiples. So for this first one, we need to find the highest common factor of 60 and 84. So method A, I'm going to show you how to do this one using prime factors. So first of all, let's consider the value 60. So we've got 60 here. We just need to think now of any numbers we can divide 60 by, apart from the number 1. Well, we can divide 60 by 2, and that gives us 30. And when we see a prime number, we're just going to circle that one. 2 is prime, so we can circle that and move on to the 30. 30 isn't prime, we can divide it by 2, which gives us 15. And 15 still isn't prime, we can divide that one by 3, which is prime, and 15 divided by 3 is 5. So therefore, we now know that 60 is 2 times 2 times 3 times 5. So we can write this down. This will help us in our next step. So 60 equals 2 times 2 times 3 times 5. So just writing this down now. 2 times 2 times 3 times 5. We can then do the same for the number 84. So 84 split into a product of its primes. 84 we can divide by 2 again, because 84 is even. Half of 84 is 42. We can half 42, which gives us 21. 21 is then in the 3 times table, so 21 divided by 3 is 7. Both 3 and 7 are prime, so we can circle those as well. Then in the same way as what we did for the number 60, we write down what 84 is as a product of its primes. 84 is therefore 2 times 2 multiplied by 3 multiplied by 7. We then put these values into a Venn diagram, like so. So we have circles for 60, and then a circle for 84. And then what we do is the factors which are in both, which we can see here, we've got a 2 in each, another 2 in each, and a 3 in each. The factors in both go in where the circles overlap. So 2 times 2 times 3, that's going to be our highest common factor. 5 and 7. 5 is only common to the factors of 60. 7 is only common to the factors of 84. So 5 and 7 aren't common in each. So therefore, the highest common factor is just what we get when we multiply the numbers in the middle together. So it's 2 multiplied by 2 multiplied by 3. Therefore, the highest common factor of these two numbers is 2 times 2 times 3, which gives us 12. I'll show you as well very briefly how you could work out prime factors using your calculator if it's a calculator paper like this one is. So here, what we can do is we type in the number we're trying to find the prime factorization of, let's say 60. We press equals, then we can press shift, and then we look for the button which has a fact above it. So it's this one here, shift fact, 2 squared, which means 2 times 2 times 3 times 5. So that's the way if you can remember it. If not, I've shown you how to do it manually here for part A. So part B, find the lowest common multiple of 24 and 40. I'll show you the calculator trick for this one. So 24 as its prime factors is going to be what, I wonder? You can work this out without using a calculator, but with 24 press equals shift fact, we get 2 cubed times 3. So that's 2 times 2 times 2 times 3. Then the same way, we do the same for 40. So get the calculator, press 40, then equals, then shift fact 2 cubed times 5. So 40 is 2 times 2 times 2 times 5. We then can create a Venn diagram like we did in part A, and do, only this time our Venn diagram will look something like this instead. So we've got the 3 2's in common to 24 and 40, but then the factor 3 is only common to 24, and the factor of 5 is only common to the 40. This time though, because we're finding the lowest common multiple, our strategy now isn't to just multiply the 3 numbers in the middle together, we multiply all numbers inside the circles together to generate our lowest common multiple. So we multiply 2 by 2 by 2 times 3 and times by 5 as well, and that tells us that for these pairs of numbers, the lowest common multiple of 24 and 40 is 120. So that's using Venn diagrams. I'm now going to quickly show you a method where you don't use Venn diagrams if you'd prefer. So I'm just calling this a lazy method because it is slightly lazy, I suppose. So for part A, it says find the highest common factor of 60 and 84. So for this one, there is a slight lazy trick we can use. So the highest common factor of 2 numbers will always be a factor of the difference between those 2 numbers. So we've got 60 and 84. So in this case, the difference is 84 take away 60, which is 24. So is 24 a factor of 60? Will 24 fit into 60? No, it won't. So let's think of other factors of 24 we could have. We've tried 24. No, 1 doesn't really get as far. The next pair of factors will be 2 and 12. So the next highest factor I could try after 24 is 12. Does 12 fit into 60? Yes, it does, because 60 is 12 times 5. And on your calculator, you can check if 12 is a factor of 84. It is. You can divide 84 by 12, and you get the answer is 7. So therefore, the highest common factor of 60 and 84 has to be 12. It's not 24. The next highest one was 12. 12 does fit in, so that's why it's the highest. So the highest common factor is 12. We can just put for that one. And then for part B, the lowest common multiple of 24 and 40, we can literally think of the times tables of 24 and 40. So the 24 times table, 24 times 2 is 48, times 3 is 72, times 4 is 96, times it by 5 is 120, and so on and so on. Then if we try the times tables of 40, 40 times 1 is 40, times 2 is 80, times 3 is 120, and so on. Then we just look for the smallest number we can see, which is the first to appear in both lists. So hopefully you can see here that 120 is the first number that appears in both lists. Therefore, the lowest common multiple of both of these numbers has to be 120. And that's all we need to do for part B, using what I've lazily called the lazy method. Question 3 is a distance time graph. So Sam drives his car on a journey. Here's the travel graph for the first 15 minutes of his journey. We have to work out Sam's speed in kilometres per hour for the first 15 minutes of his journey. Well, the speed is the distance travelled in those 30 minutes divided by the time taken. So the time taken is obviously 15 minutes. I'm going to call that 15 minutes. And the distance, well, we can see here, in the first 15 minutes, he's covered 20 kilometres. So his speed is 20 kilometres per every 15 minutes. But we want this speed in kilometres per hour. 15 minutes obviously is not an hour, so what could we multiply this by in terms of getting a full hour? Well, 15 times 4 would give us a full hour, and if we times the bottom of a fraction by a certain value, to keep it the same value, we multiply the top of it by the same value too. So 20 times 4 is 80 kilometres, and 15 minutes times 4 is 1 hour. So he must do 80 kilometres in 1 hour, which by definition is 80 kilometres per hour. So the answer to part A is simply 80 kilometres per hour. Next, we have some extra information to add to our diagram. So at 10:15, Sam stops for 10 minutes. So if he's stopped, that means he's stationary. So let's add this on first of all. So at 10:15, he stops for 10 minutes. Here's 10:15. 10 minutes on after 10:15 will be 10:25. So from 10:15 to 10:25, the graph will be stationary. It'll be horizontal. The distance travelled isn't increasing because he's stationary. It then says he drives for 20 minutes at a speed of 75 kilometres per hour. So let's just think of this here. 20 minutes at a speed of 75 kilometres per hour. Well, 75 kilometres per hour means he could do 75 kilometres in 60 minutes. However, he's only travelled for 20 minutes, so how far would he go if he's only travelled for 20 minutes rather than 60? Well, 20 minutes is only 1/3 of 60. In other words, we can go from 60 to 20 by dividing by 3. He's only got 1/3 of an hour to cover that distance, so he'll only cover 1/3 of that 75 kilometres that he would be able to cover in a full 1 hour. 75 divided by 3 is 25 kilometres. So in other words, in that 20 minutes, he would have covered 25 kilometres. So 20 minutes on from where we left off, 10:25 plus an extra 20 minutes takes us to 10:45, which is here, and then he's got an extra 25 kilometres. So he's gone 20 kilometres so far, an extra 25 will put him at 45 kilometres in total. So the final bit of his journey, where he does an extra 20 minutes and covers 25 kilometres, would be from here to there, like so. So that now is the completed distance time graph for Sam. Question 4. Complete the table of values for this function y equals x squared minus 2x plus 2. I will at some point, if I've not already shown you, I'm pretty sure I will have done, I'll show you how to do this without using a calculator, but considering this is a calculator paper, I'm going to show you how to use the table function to quickly generate a table of values if you should, for example, like this question, need to plot a graph. So, using a Casio, what we're going to do here is get the calculator switched on. It's a good start. Now, we press menu and we scroll along until we get to table. Depending on which model of the class whiz you have, it might be a different option, but it will have a table function no matter which one you have. So go to table and press equals. F of x is just what it means by function of x, which is what we mean as y. So just read f of x as y. So our y equals x squared. To get an x, we type alpha, and then the right bracket, square it, minus 2 lots, then alpha bracket to get the 2x, then plus 2. G of x is if you wanted to plot two functions at once, but we're only interested in this one, so just type that as 0. We don't know about g of x, we don't care. Now for this function we're plotting, x starts from minus 2, so we're going to start from minus 2, press equals. Our x is end, when we get to x being equal to 4, so end, type 4, then equals, and the step just means what the values of x are increasing by. So we go from 0 to 1 to 2 to 3 and so on. These steps are going up in ones each time, so leave the step as 1. We normally do, sometimes we don't, but step in this case, as normal, is just 1. So press equals, we then get our table of values. So when x is minus 2, y is 10, like it shows here. The next one, when y is minus 1, x is 5. So we need to fill in 5 here. Next, 0 and 2. 0 and 2 has already been given. When x is 1, y is 1, so we put in a 1 here. Next, we need to scroll down in our calculator. When x is 2, f of x, our y is 2, so we press in a 2 here. I'll write it in, I should say. And finally, when x is 4, if I scroll down to 3 and 4, it says here that f of x, our y again, is 10. So the final one we plot on is that y is equal to 10. We then take these 1, 2, 3, 4, 5, 6, 7 points and plot them on using either dots or crosses like so. Then, with as smooth as a curve as you can possibly muster, I'm not very good at these, so I'm cheating by this one I'm going to show in a moment. You need to do a smooth curve going through each and every one of these points. Use a pencil if you're not very good at these. You should have something that looks like this. As I say, I've cheated. I could never do a red curve as good as that, but it should be something close-ish to that if you can. So that's part B. We've plotted the values, and we've done part A. Obviously, we've completed this table. For part C, we need to use this graph to find estimates of the solutions of this equation, x squared minus 2x plus 2 equals 4. First of all, just look at the first bit of this equation. X squared minus 2x plus 2 is the same as what we did earlier, so that's the same as our y, which we've already plotted on. So this red curve is when y equals this bit. Now what we can do is we can do a similar graph of 4. So what we could do is another graph where y is equal to 4, then when this curve crosses the line, that tells us when one function is equal to the other. So if we draw a line y equals 4, where the lines cross, that will tell us the solutions to this equation. So a line y equals 4 is a straight line crossing the y-axis at 4, like so. We can see here the curve crosses the line here and here, so we just read off the x values at this point and at that point. So we can see here our x value for this one is down at something like minus 0.7, and the one up here is about 2.7. Read them as accurately as you can, so based off this one and that one, and evidence that you've read off your graph in the right way. You can't just pluck numbers from thin air. Your working is by doing this on your graph paper. We can then see that x is either minus 0.7-ish or x is 2.7-ish as well. Your answers need to be plus or minus 1 decimal place from mine to get your marks. Question 5. We've got a right angled triangle like so, and then some of these triangles, well 2 of them, have been put together to make a shape like so. We need to work out the perimeter of this shaded shape, giving our answer correct to 3 significant figures. So this should say to you almost straight away it's a Pythagoras question. This is a right angled triangle. We know 2 sides and don't know the third. So we can find out the length of this hypotenuse in order to find the perimeter of this shape here. And of course, this shape here is made up, the perimeter is made up from these sides in green, blue and red. So 10 millimeters along the bottom, 8 there, another 8, then this is going to be the hypotenuse, plus this tiny bit here, which in order to work it out, we need to know the length of the hypotenuse. So we need to find this red side, which I'm going to call A in a moment. So the perimeter, just going back to what I said, it's 1 red side plus 2 of the blues, 8 plus 8, plus this green on at the bottom, plus this one here, which we need to work out the hypotenuse for first. So let's just call the hypotenuse A. So by Pythagoras, A squared will equal 8 squared plus 10 squared. So 8 squared is 64, 10 squared is 100, so A squared must be 164. We can now work out what A is by just typing the square root of 164, press equals, then press S arrow D to get a decimal answer to that. Now this isn't our final answer, so don't round it off too soon. Give it to at least, I would say 5 or 6 decimal places, but A is 12.806248 and so on and so on. So square root of that answer, we get that. So we can now label this on our diagram. So that's now 12.806248. So how can we work out what this tiny smidgen is here? Well, if we consider this dashed red line is obviously the same as hypotenuse, which is 12.806248, but from here to here is the same as the base of this one, which is 10, then the difference will just be 12.806248 minus the 10. In other words, this tiny bit here is 2.806248. So based on that, we now know all the ingredients to work out the perimeter of this shape. So the perimeter is going to be 12.806248 for the hypotenuse, plus 8 plus 8 plus this 10 here, and then finally plus the 2.806248 over there gives us a total perimeter of 41.6 centimetres, correct to 3 significant figures. Here for question 6, we've got two right-angled triangles for both A and B. For part A, we know a side and an angle. We're trying to find another side. And for part B, we know two sides and are trying to find an angle. So because of this, I'm hoping you should be able to spot these are both going to be SOHCAHTOA, right-angled trigonometry type questions. So I can get the SOHCAHTOA triangles here and ready. So for the first one, we're trying to find the length of BC. What I'd suggest first of all would be to label the sides. First of all, opposite the angle we're told, always label that O for opposite. So in this case, we're not told what the opposite is, but we do want to work out length BC. So from B to C is this side here. So actually, yes, we do want to find the opposite. So I'm going to highlight O, because we want to find O, and also highlight O in all of the SOHCAHTOA triangles. The longest side is a hypotenuse, which is here, H. We don't know that, we don't want to know it, so we don't care. The other side, if it's not O or H, is A. Now we do know that side, so I'm going to colour code that in green. So A we know, so I can add A to both, or all of the SOHCAHTOA triangles. In terms of which one we pick, what we do is we pick the one which includes the side we know, the A, and the side we need to know, which is the O for opposite. So the only triangle out of SOHCAHTOA that includes these two sides is TOA. So we're going to use TOA. So because of that, what we can do is we can more or less forget about the others for now and just focus in on using this TOA triangle. So the side we want to find is O for opposite. So because we're trying to find O for opposite, we essentially just cover up O for opposite. And whatever's left tells us what to do. So we've got T next to A. That means that the opposite side is T multiplied by A. In this case, T stands for tan of the angle we're talking about. So it's going to be tan 56. And we're going to multiply that by the adjacent side, which is 12. So our calculation is tan 56 multiplied by 12. So tan 56, close the brackets, multiplied by 12, press equals 17.7, and so on and so on. Now we need our answer correct to one decimal place, so it's either 17.7 or 17.8. Because next to the 7 is a 9, that 9 forces the 7 to round up to an 8, so we've got 17.8 for our answer. 17.8 centimetres, including the unit, of course. For part B, in the same way, we need to label on our sides. So I'm going to label opposite the side we're trying to find as O. Now we don't know the opposite side, nor do we care. Opposite to the right angle is always the H for hypotenuse. Now we do know H for hypotenuse, so I'm going to colour code this in, and as well on the SOHCAHTOA triangles. And as well, if it's not O or H, the other side has to be the A for adjacent, and we do know this one as well. So I'm going to colour code in the adjacent, because we know it and therefore can use that one. In the same way as part A, we pick the most coloured in triangle. The triangle that includes both the sides we know, the H and the A, so it's going to be the middle one, CA. So in the same way as part A, we can ignore the other SOHCAHTOA triangles we don't need, because we just need CA. We can hone in on the CAH triangle. So I'm just getting rid of the others because these are nothing more than a distraction now. We decided the triangle we need. Now to find an angle, we either use sin minus 1, cos minus 1, or tan minus 1. Because we've gone for the CA triangle, we're going to use cos minus 1. And if we cover up C for cos, we're told what to do in terms of the order everything else is found. We need A on top and H on the bottom. So we do cos minus 1, A over H. So what was our A side? Well, our A side was 15 and our H is 18. So all we need to do now is plug these numbers into our calculator. The adjacent side was 15 and the hypotenuse is 18. So if we just get the calculator now, So we do shift cos to get cos minus 1, press brackets, so A 15 and H on the bottom 18, close off the brackets. We get this value here, round it to one decimal place. It's either 33.5 or 33.6. Because next to that 5 is another 5, this 5 forces this one to round up to a 6. So it's 33.6 degrees. And that's all we need to do. Question 7. Liquid A has a density of 1.8, liquid B has a density of 1.2. It then says 80 cubic centimetres of liquid A is mixed with 40 cubic centimetres of liquid B to make 120 cubic centimetres of liquid C. Work out the density of liquid C. So we've got densities, we've got volumes, we've got masses. It's going to be involving this formula triangle where density equals mass over volume. So taking this question piece by piece, liquid A I'm going to colour code in red, liquid B I'm going to colour code in blue. So thinking of liquid A for a second, using this formula triangle, if we cover up the mass, mass is density next to volume, so it's density multiplied by volume. So for liquid A, the mass of liquid A will be the density of liquid A, which is 1.8, multiplied by the volume of liquid A we're going to be mixing, which is 40. So for liquid A, the mass of it is going to be the density 1.8 multiplied by the volume, which is 80 cubic centimetres, and that gives us a mass of liquid A of 144 grams. We do the same for liquid B now. So for liquid B, the mass of liquid B is a density of B multiplied by the volume of liquid B. So it's going to be 1.2 multiplied by 40, and 1.2 multiplied by 40 gives us 48 grams. Now A and B are combined, they're mixed together to make liquid C. So if we've got 144 grams of A plus 48 grams of liquid B made together for liquid C, the total mass of liquid C must be 144 plus 48 grams, which is 192, and the volume of liquid C is therefore 80 plus 40, which gives us 120 cubic centimetres. Now we can use a formula triangle to work out the density of liquid C. The density of C will be the mass of C divided by the volume of C. So the mass of liquid C is 192, divided by the total volume, which we're told is 120. 192 divided by 20 gives us 1.6 grams per cubic centimetre. So that's what we put on our answer line here, 1.6. Question 8, we've got a group frequency table giving information about the times in minutes taken by 50 people to solve a puzzle here. Brian was asked to draw a cumulative frequency table based on this one, and this is what he's drawn here. So it all looks fairly standard really, but apparently has made a mistake. Write down one thing that is wrong with this cumulative frequency table. Cumulative means the numbers need to add up as you go along. So 5 plus 8 is 13, plus 12 is 25, plus 15 is 40. His numbers here are correct, so the error isn't with these. What we need to spot here though is that these numbers aren't correct. Cumulative means everything from the start up to this point, whereas here he's done it from 10 to 20. That should be from 0 all the way to 20. This should be 0 all the way to 30 and so on. So all of these all these left-hand side limits on these inequalities need to be 0 for a cumulative frequency table. And that's all we need to put down. So essentially, the inequalities in a cumulative frequency table need to start from 0. So these numbers here are all errors. They should have all been 0 instead. Question 9. The box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. For part A, we need to work out the interquartile range of the information in this box plot. At this point, we've got 5 vertical lines we can see on a box plot. It's worth just reminding ourselves what these 5 vertical lines mean for each and every box plot ever made in the history of the universe. They always mean the same 5 things. The first vertical line is the absolute minimum value, so this one's 20. The second vertical line is the lower quartile, Q1, which is 50. The third vertical line is the median, which is 120 minutes. The fourth vertical line is the upper quartile, which we can see here is 188. And the final vertical line is the absolute maximum value, which is at 200. Now we can think about what the interquartile range means. The interquartile range is the difference between the upper quartile, 188, and the lower one, 50. So simply put, we do the upper, take away the lower quartile, 188, take away 50, which gives us 132. So the interquartile range for part A is 132 minutes. For part B, Becky says that 50% of the people waited for at least 2 hours. Is she correct? Explain why. Well, Becky's talking in terms of hours. This scale here gives it in terms of minutes. So 2 hours is how many minutes would be the first thing I'd asked. Well, 2 hours, 1 hour is 60 minutes, so 2 hours is going to be 120 minutes, but 120 minutes, that's actually the median. So actually Becky is correct, because 2 hours is the median, and that splits the data into 50-50. In other words, 50% of people did wait for at least 2 hours, and 50% of people waited less than 2 hours. So for that reason, yes, she is correct. Becky is correct because 2 hours is the median, so 50% of people waited for at least 2 hours. The working for your answer and marks needs to be something along these lines. It doesn't need to be what I've put word for word, but something like that will suffice. Part C, we've got a table about the lengths of times in minutes. Some people waited to see a doctor, the same hospital on Tuesday. So again, we've got the same 5 ingredients for what would make a box plot. You don't need to draw a box plot for these, but I'm just going to construct one here because you might find it easier to compare and contrast one box plot versus another. So if I just put these into a box plot here, which you can do if you want, Monday is what we had from before. Using these values here for Tuesday, so 20, 50, 100, 140 and 210, they'd go here. And then constructing the 5 vertical lines and making the box and the whiskers as such, we'd have this. So if you wanted to, that would be a box plot for Tuesday. Now Becky's asked to compare the distribution of lengths of times people waited on Monday with the distribution that they waited on Tuesday. And she wrote people had to wait longer on Tuesday than on Monday. Give one reason why Becky may be wrong. May is a powerful word. We're not saying definitely she's wrong, but because we're suggesting why she might be wrong, there's actually several things we could put. Of the several things you could put down, I'm going to mention the 3 most obvious, in my mind at least. So what I'd suggest would be one of the following. I've underlined in red what I think the most obvious one is. Tuesday's median waiting time is lower than Monday's. The median for Tuesday is 100, the median for Monday's was 120. So because Tuesday's median is lower, that suggests that on average, people wait less time on Tuesday than they do on Monday. So the most obvious one for me is just say Tuesday's median time is lower on Mondays, so therefore on average, they probably wait less on Tuesday, not more. Or you could have said it's possible that only one person on Tuesday waited for 210 minutes, so although the highest value on Tuesday is higher than the lowest on Monday, that might just be one out of many, many people. So we can't go off that to make a general sweeping statement like she's done. Or the third thing you might want to say is we don't know any individual's exact waiting times at all. So because these are based off summaries of all the data combined, we can't make such sweeping statements about all the people. All we can say is, yes, sure, one person waited longer than the person who waited longest on Monday, but we can't say any more on that. To keep it simple, I'd say go for the top line there, compare medians. Tuesday's median is less, therefore probably she's wrong. Question 10 is about bank statements and compound interest. So Louise invests X pounds in better investments for 3 years, and Sadiq invests X pounds in County Bank for 3 years. So because this is compound interest, and before I move on, I'm just going to state the same thing I'd always say to my class. So before anything happens to an amount, we always begin with 100% of itself. So for better investments, we get 2.5% per annum. Percent interest means it gets added on to the 100%. Interest is added on, not taken away. So 100% plus 2.5% means that after it's been compounded, the balance in better investments after 1 year would be 102.5% of its original self. But we can change this into what's known as a decimal multiplier, By typing the percentage first of all, press equals. The decimal multiplier is 1.025, and it's these decimal multipliers which are powerful because they tell us what to multiply the initial values by to generate this overall percentage change. So first of all, this decimal multiplier is 1.025. For County Bank, there's going to be two different decimal multipliers because there's two different rates depending on which year we're in. So 2% per annum for the first 2 years, 100% plus 2% is 102%, and that as a decimal is 1.02, and for the years after that, 3.5% added on is the same as 103.5% of its original self before that was added on. And 103.5% as a decimal is 1.035. First of all, though, we're told about Louise's investment, and Louise invests in better investments. So we're just thinking of better investments for now. So after 3 years, she's ended up with £344,605. So whatever she started with, X, after it was multiplied by 1.025 for the first year, multiplied by 1.025 for the second year, and then multiplied by 1.025 for the third year, she ends up with this total here. 3 years, which is why we're multiplying it by 1.025 3 times in a row. So it's the initial amount multiplied by 1.025 times 1.025 again times 1.025 again. 1.025 cubed, this power is the number of years, and that gives the total end amount of 344,605. This is now an equation I can solve to find out what the original amount X must have been. To get rid of multiplying by 1.025 cubed, I could divide both sides of this equation by 1.025 cubed. And if I get that, then X must be 344,605 divided by 1.025 to the power cubed. So we get that the original X must have been £320,000 exactly. We can now apply this to what happened to Sadiq's money in County Bank. Sadiq invested it for 3 years in this County Bank here. So for Sadiq, what we'll have is the original amount, £320,000, multiplied by 1.02 squared. That powers 2 because it's invested at that rate for 2 years, hence a power 2. Then the third year, the decimal multiplier is 1.035. We only multiply by that value once because it's only getting interest at that rate for the third and final 1 year only. So we just type these values into our calculator. So 320,000 multiplied by 1.02 squared multiplied by 1.035, and we get this answer here. So the question doesn't say to give it to so many decimal places or to the nearest £100. That is an amount of money that makes sense. £344,580 and 48 pence. So I would suggest just to write that down as your final answer, and that will be absolutely fine. So Sadiq, in other words, ends up with that grand total, and that's question 10 complete. Question 11, we've got a sketch of a straight line L. So we've got points P, which is at -6, 0, and Q, which is at 0, 3, are points on this straight line called L. And then the point R over here is such that the line PQR is a straight line, so R is on the straight line L as well. And the ratio of the line segment PQ as a ratio of the length to QR is 2 bits to 3 bits. So this is a bit we're going to focus on now, and this will tell us what the coordinates of R essentially are. So PQ is 2 lots and QR is 3 lots. Now because this is a straight line, I'm going to think of this in terms of steps. So in other words, every 2 steps PQ is, QR is 3 steps. So let's imagine from P to Q and from Q to R as steps. P to Q is 2 steps of a ladder maybe, if you want to think of it as a ladder, and Q to R is 3 steps. So if I add it on like so, let's think about just from P to Q for a moment. So the x-coordinates at P is -6, and at Q it goes to 0. So that's gone up by 6 in 2 steps from P to Q. So if 6 along is what happens in 2 steps, then in just 1 step it'll be 3 units long. So each step from P going along 1 step must be 3. And if we have a look at the y coordinates, at P the y coordinate is 0, at Q it's 3. So it's gone up by 3 in just 2 steps. If it's gone up by 3 in 2 steps, then each 1 step must be 1.5. Therefore, each one of these steps is 3 along and 1.5 up, and it will therefore be the same for Q to R. Only now we've got 3 lots of these steps. So it'll be 3 lots of 3 along and 3 lots of 1.5 up. So if we imagine starting from Q, in total we're going from Q 3 plus 3 plus 3. We're going 9 along as we go from Q to R. And in terms of how far we go up, we're going up 1.5 plus 1.5 plus 1.5. We're going 4.5 up. So from Q to R is 4.5 up and 9 to the right. So the coordinates of R is going to be 0 plus 9, which is 9. And because we're already starting at a y height of 3, the y coordinate will be 3 plus 4.5, which is 7.5. So the coordinates of R are therefore 9 and 7.5. Moving on from part B, I'm going to get rid of all this labelling so I can focus off on the main part B. So if I just say goodbye to all of that, we need to find an equation of the line that's perpendicular to L and passes through the point Q. So a line perpendicular to L will be going in this direction and will go through Q. It'll look something like this line I've drawn in red. So if this line here is perpendicular, then its gradient will be the negative reciprocal to the gradient of line L. So let's think about the gradient of line L. What's the gradient of line L? Well, it's the change in y divided by the change in x. So let's just think about P and Q. From P to Q, it's gone up 3 units, and it's gone along from -6 up to 0, it's gone along 6 units. So the gradient of our line L is a half. So therefore, the gradient of a line perpendicular to that will be the negative reciprocal of the gradient of line L. So turn a half on its head, it becomes 2, make it minus, the gradient's therefore -2. So therefore, our line is of the form y equals minus 2x's, because the gradient of it is -2, plus c, where c is the y-axis intercept. Now, before we panic about having to substitute in a known point, which we normally would do, if we just remember that c is the y-axis intercept, and we're told this line goes through Q, Q is the y-axis intercept, essentially. The y-axis intercept is the value of y when x is 0. When x is 0, y is 3, so therefore the value of c is 3. So our equation of this line is therefore y equals minus 2x plus 3, because Q cuts the y-axis at 3. So actually it's not so bad, part B. Question 12, expand and simplify 3 brackets. X minus 2 multiplied by 3x plus 2 multiplied by 2x plus 3. Whichever way around you do this, there's only one way in my mind where you can expand 3 brackets, and that's just to expand 2 at one time. Just do 2 of the 3 first. My suggestion is always to work with the last 2 first. So let's expand 3x plus 2 and 2x plus 3. So the way I prefer to do it, you could use FOIL if you wanted, would be to use a grid method like so, and then just fill in the boxes in any order you wish. So if I go through this first box, we're going to multiply 3x by 2x, which gives us 6x squared. This box is 2x multiplied by 2, which gives us 4x. This one, 3x times 3, is 9x. And finally, 3 multiplied by 2, this here will be 6. We can now simplify this. So these 2 last brackets expanded will be 6x squared. 4x plus 9x is plus 13 normal x, and finally plus 6. So fully simplified, we have 6x squared plus 13x plus 6. We can now multiply this first bracket by all of this, which is a combination of the last 2 expanded. So now we're going to do x minus 2 multiplied by 6x squared plus 13x plus 6. So we can use a grid method, but now, because we've got 3 terms, we need a grid which has 3 columns and 2 rows, something like this. So along the top is our expansion from last time, and down the side is what we're multiplying this by, which is our first bracket, x minus 2. So looking at this first one, 6x squared times x gives us 6x cubed. 13x times x is 13x squared. X multiplied by 6 is 6x. 6x squared times minus 2 gives minus 12x squared. 13x times 2 would be 26x, so times minus 2 gives minus 26x. And finally, 6 multiplied by negative 2 gives minus 12. We can now simplify this down fully as well. We've got 6x cubed. 13x squareds, take away 12 of them, leaves us with just 1x squared. 6x's, take away 26 of them, gives us minus 20x. And finally minus 12. So our fully simplified final answer is 6x cubed plus x squared minus 20x minus 12. Question 13. In a school there's 16 teachers and 220 students, and of those students 120 are girls and 100 are boys. One teacher, one girl and one boy are going to be chosen at random to represent the school. Work out the number of different ways there are to choose one teacher, one girl and one boy. Well, there's 16 teachers to choose from, there's 120 girls to choose from, and then there's 100 boys. So we're simply going to multiply these values together. Our answer will be 16 times 120 times 100, which gives 192,000 combinations of one teacher, one girl and one boy. Question 14 is related to circle theorems. So A, B, C and D are 4 points on a circle, and we're told that SBT, this straight line at the top, is a tangent to the circle. We've kindly been told that angle at ABD is 20 degrees, so we can just colour that in if we wanted. Maybe you don't want to, I do. And we're then told that the angle BAD to angle BCD is in the ratio 3 to 1. So if I colour in angle BAD in green, which is this one, and the angle at BCD is this one here, they're in the ratio of 3 to 1. So I'm going to call this angle at A 3x, and this one down here just 1x. At this point, we need to return to what the question told us. A, B, C and D, A, B, C and D are all points on the circumference. Therefore, A, B, C and D forms a cyclic quadrilateral. A cyclic quadrilateral, we need to remember a key circle theorem property, and that is that opposite angles in a cyclic quadrilateral add up to 180 degrees. Therefore, this 3x plus this x adds up to 180 degrees. So we can write that down, and because we need to show our working, we write down the circle theorem referencing. So 3x plus x is 180. Reason, angles in a cyclic quadrilateral add up to 180 degrees. We can now solve this very simple equation. So if 4x equals 180, we can then do 180 divided by 4, which is 45 degrees. So x is 45 degrees, therefore 3x's will be 3 times 45, which is 135. We can now replace these algebraic x's with the actual values of the angles, because you worked out what x is. So if we say goodbye to the 3x and x, and hello to 135 and 45 degrees. Now looking at this triangle ABD, we know two angles, we can therefore work out the third. If we do 180 take 135 take away 20, that'll tell us the size of angle D, so we can do that. Angle D, this purple one, must be 25 degrees therefore. And we can say, using our working, angle ADB, this purple one, is 180 minus 135 minus 20, which gives us 25 degrees. And as obvious as this may be to you, we get marks from the examiner for giving a reason why. The reason there is we know that angles in a triangle add up to 180. So if that's 25, we can now work out this angle SBA here. And we need to remember another circle theorem to spot where this angle here is. So to make it easier to spot, I'm just going to focus in on just triangle BAD and this tangent here. So I'm going to get rid of this angle at C and these red lines now. So label this in 25 because that's obviously needed. If I get rid of all the other stuff now, we need to remember another circle theorem which is called angles in the alternate segment are equal. Essentially, the angle made in between a tangent and the first line of a triangle, where the first line of a triangle touches the tangent, this angle here, will always be the same size as the angle made which doesn't have any contact with the tangent. So this line here touches the tangent, therefore 20 and 135 are connected to it. This angle here, though, isn't attached in any way to the tangent, so this 25 is the same as this 25 here. It's just spotting that piece, really. It's just spotting that you can do that. And the circle theorem we need to quote, so you know that you can allow to do that, is as follows. So you need to put down SBA is 25 degrees, quoting the theorem that angles in the alternate segment are equal. So that angle is the same as that angle via this circle theorem. Question 15, we have another triangle, triangle ABC. We need to find the length of BC, giving answers correct to 3 significant figures. It's not a right-angled triangle, so you should be thinking it might be either the sine rule or cosine rule. In fact, it is the cosine rule. We know it's the cosine rule because we're wanting to find a side when we know the other two, and we know the angle in between the two sides we're given. That is how you always know it'll be a cosine rule if you're trying to find a side like this. So what is the cosine rule? We need to label on A, B and C. We want to find BC. The side you're trying to find, I'd always label it A, and the angle opposite to the side you're trying to find is angle big A. So that's 72 degrees would be angle big A. Going back to what I was saying, what is the cosine rule? It's A squared equals B squared plus C squared minus 2 lots of B times C times cosine of A. We can now just substitute in what we know. We're trying to find A, well A squared I suppose, so A squared will equal 8 squared plus 11 squared minus 2 times 8 times 11 times cos of 72 degrees. We can now work this out on a calculator and then square root it. So for now, what we're going to need to do is just to work out the basics. So we've got 8 squared plus 11 squared minus 2 multiplied by 8 multiplied by 11 multiplied by cosine of 72, close brackets. And that gives us 130.613009. Final step, we can now square root that. So square root our answer, press equals. We get 11.4 correct to 3 significant figures. So therefore square rooting that gives us 11.4 centimetres. Part B, we need to find the area of triangle ABC. There's a formula for that as well, which is an extension of area's half base times height essentially. So because this is a formula, it'll be in terms of different letters as well. So because we're done for part A, if we just say goodbye to the labelling from part A, so we can now label on what we need for part B. For part B, the area of a triangle formula is the area is given by half times A times B times sine C, where A and B are the sides either side of the angle you know, which is angle C. So if I call this one angle C, A and B can be 8 and 11 in any order, something like this. That's angle C, that's side C. We don't need to know angle C, we just need to know A, B, and angle at C, which we do. So we can now just substitute these values into the formula. So half times A times B times sine C means half times 8 times 11 times sine 72. So if we just type this into our calculator, half times 8 times 11 times sine 72, we get a figure of 41.8, 4, 6 and so on. And because again this one needs rounding to 3 significant figures, it just becomes 41.8 because that 4 isn't enough to round that 8 up to a 9. So we just have 41.8 centimetres squared. Question 16, we're talking about an iteration formula. So we've got this formula, x subscript n plus 1 equals a cube root of 10 minus 2 times x subscript n. And we need to find these values of x1, x2, x3. So we're starting with x0 equals 2. So this formula here just means that x subscript n plus 1 is the next value after x subscript n. So x1 will be this formula with x0, x2 will be this formula with x1. So this is just like the next number along. So we feed in the previous one to get the current one. So talking this through step by step, x0 equals 2, so we can plug in that we want x1 and this is x0. So x1 will be the cube root of 10 minus 2 lots of x0. But x0 of course is 2, so we just do the cube root of 10 minus 2 times 2. So we can press shift cube root button, 10 minus 2 times 2, or you could just do the cube root of 6 if you wanted, because 10 minus 2 times 2 is 6. And we get this answer here, 1.817120,593. So that's our first answer. Now we use this formula again. So now we know what x1 is. So if I highlight in green what x1 is, 1.817 and so on and so on, we can then see that the second one, x2, will be the cube root of 10 minus 2 lots of x1. So subbing in what x1 actually is, that's 10 minus 2 lots of 1.817,120,593. And if you do that on your calculator, what you should get is the same as you get if you just press 10 minus 2 times ANS. So whether you press this one or that, the ANS button is a shortcut to having to remember or typing carefully all these digits. So you can get the next one by just going to your calculator, toggling back, removing x0, which was 2, so press delete and then type in the answer, and you should get, whether you use the ANS button or this value here. Now using the ANS button is obviously much quicker, which is why I'm mentioning it. So x subscript 2 is 1.853318,496 and so on. So we put this down for x2, then x2, which I'm putting in blue, is what we need to work out x subscript 3. So in the same way, x subscript 3 is a cube root of 10 minus 2 lots of x subscript 2. So that's cube root of 10 minus 2 lots of this, which is the same as if you just do the cube root of 10 minus 2 times the previous answer we got. So again, if we just toggle back, press delete, and type in the new ANS, because the ANS will have updated since last time, that's equals, we get 1.846265,953. And that's our third and final value for x. Now for part B, we're told here that the values we're trying to find in part A are estimates of the solution of a cubic equation in this form: x cubed plus ax plus b equals 0, where a and b are integers. Find the values of a and b. Now to do this, what we need to do is just to call each subscript the same value. So we're going to call this x and this one x. So in other words, x equals the cube root of 10 minus 2 lots of x. We will now need to rearrange this so it's in this form. So to go from this form to this, what we need to do is cube both sides to get rid of this cube root. So if we cube both the left and the right, what we'd get is x cubed equals 10 minus 2x. Now we want this all on the left-hand side, so the right is equal to 0. So what I'm going to suggest we do first of all is to add 2x to both sides. We then get x cubed plus 2x equals 10. Then finally, if we subtract 10 from both sides, we get x cubed plus 2x minus 10 equals 0. But what we're asked here is values of a and b. So a is the value of x's we've got, so our a is positive 2, and in the same way b is just the value on its own, and the b here we can see is minus 10. So we just put our a is therefore 2 and b is minus 10. Question 17. Some people took part in the first round of a competition we've got a histogram giving information about the scores of the people in the first round. And apparently 20% of the people got a score high enough for them to qualify for the second round. What we need to do here is use this histogram to estimate the score needed to qualify for the second round, showing all working. Because it's a histogram, we can probably guess this formula triangle is going to be used. Frequency density is frequency divided by class width. And we can cover up, whether it be the frequency density, frequency or class width, we cover up which one we want to find. So I'm going to get my little hand symbol here. What we could do with knowing is the frequency represented by each of these bars. So if I just get this here, we can say frequency is frequency density multiplied by class width. So doing this bar by bar, this first one here, the frequency density is 0.8. The class width from 0 to 5 is 5. So 0.8 times 5 equals 4. So this bar here represents a frequency of 4 people. The second one, we need to show this because of our working as well. This frequency density is 1.123456. The class width from 5 to 15 is 10. So the second bar represents 1.6 times 10, which is 16 people. The third bar has a frequency density of 2.2. Again, has a width of 10, because 25 take 15 is 10. 2.2 times 10 is 22. So this represents 22 people in total. And the third and final bar has a class width of 15 and a frequency density of 1.2. So the frequency represented by this bar is 1.2 multiplied by a width of 15, which should give you 18 on your calculator. So this one here, 18 people in total. So from here, we can work out the total number of people. So therefore, total people we've got 4 plus 16 plus 22 plus 18. So just total this up on the calculator. I'd suggest use your calculator rather than in your head, because it is a calculator paper after all. So let's just move this to one side. We've got 4 plus 16 plus 22 plus 18. That gives a total of 60 people. Now the question said that 20% of the people got a score high enough for them to qualify for the second round. So if there's 60 people, we need to work out 20% of 60 really. So 20% of 60, again we can use a calculator, 20%, 20, shift, percentage button of 60 gives us 12. So therefore 12 people qualified. So this bar here is where these people must be represented in. So 12 people qualified, but this bar is for 18 people. And so 12 is 2/3 of 18. So if you imagine splitting this bar vertically into 3 strips, each strip, if you have 3 strips, would be equal to 6 people. So what we need to do here is actually consider that we need to divide it like so. And so what we'd have here, if this bar's 18 people in total, then we could be splitting it so that we've got 6 people one side of it, and the 12 people that have qualified over here. So in order to qualify and go on this side, the cut-off point, as you can see, using this dividing line in the dotted red, is 30 marks. So our best estimate is 30 marks or over are needed. So therefore, 30 marks required. We don't know for definite, because we're not told any exact marks here, but all we do know is we're using this as an estimate, and that's the best we can do. So 30 marks are required is our best estimate for the score needed. Question 18, we've got a graph of y equals sine x for x going from 0 degrees up to 360. Using this graph, find estimates of all 4 solutions of sine x equals 0.6, but now it says x in between 0 degrees and 720. Bear with me as I show you a couple of different ways you could approach this. One thing to consider, one way, is to know that the sine graph, and cosine and tangent for that matter, repeat indefinitely. Sin x, this curve, that's got one cycle as you can see. Starts at 0, peaks down to the trough, back at 0. It repeats this cycle of 360 indefinitely. So we could imagine this repeated in between 360 and 720 like so. I'm not saying you can actually draw this, I've cheated in fact and made my own graph, but the point I'm making, if you just bear with me, will make more sense even though you can't actually draw this graph on. So imagine where sin x is equal to 0.6 on this graph, it's where this curve crosses the line where y would be equal to 0.6. So we can draw a line at 0.6, I can see it crosses 1, 2, 3, 4 times in between 0 and 720. So the solutions are where the line at 0.6 crosses the black curve, and these squares here, 5, 10, 15 squares for 90 degrees, each little square is worth 6 degrees. So what you need to do here is read it as accurately as you can. That there for me looks like just after 6 squares. 6 squares would be 36 degrees, so I'm going to go 37 degrees for that one. And similarly, these are my other estimates. So your answers should be 37, 144, 397 or 504, pretty close to those anyway. And like I've shown here, to go from these ones to those ones, rather than actually drawing on an extended graph, you can just add on 360, because you should know that the period of the sine graph repeats every 360 degrees. So you just need to find your own two estimates, 37 and 144, add 360 onto those to get the next two. So mine are 37 degrees, 144 degrees, 397 and 504, and for you to get your marks you need to be within a certain range. So the range of validity to get your marks are these. So your first one, your estimate needs to be in between 35 and 40. The second one needs to be between 140 and 145. The third one needs to be somewhere between 395 and 400. And the fourth and final one needs to be between 500 and 505. Of course though, you've got a calculator, so you can double check, and indeed you should double check that these answers are reasonable. So if I just try, for example, sine 37, I should find that's very close to 0.6. Sine 37, very close indeed. I could check the other ones as well. The others need to be close to that, and if you had time at the end of the exam, rather than closing your paper and just waiting out the clock, you could be checking on your calculator if these values are close, and if not, just check ones which are closer. So you can always just double check that and almost work backwards if you're being a bit naughty by using your calculator to check the solutions there for you. Part B, we've got the graph of sin x again. This time it's reflected in the x-axis. So if this is reflected, this point goes down to here, this point goes up to there. You'd have something like this. So each point here, for example, where y was 1, that gets moved to minus 1. Where y was 0.5, that gets moved to minus 0.5, and so on. Where it was minus 0.5, it becomes plus 0.5. In other words, each and every value of y is multiplied by minus 1. So the equation of a reflected graph is y equals minus 1 times sine x. In other words, y is minus sine of x. There is also another answer you could have got, which is unlikely but possible. You could also say that y equals sine of minus x, and that would also give you the equation of the graph reflected in the x-axis. Question 18, you've got a graph of y equals f of x. So on the grid we need to draw the graph of y equals f of x minus 2. Let's compare what's in these function brackets. The first one is just x, and the second one, x has been replaced by x minus 2. But remembering the change has been made from within these function brackets, and the change is made inside the function brackets, inside means opposite. So it looks like here we'd be subtracting 2 from the x coordinates, but because it's inside it works opposite to what you might expect. So instead of taking away 2 from the x-coordinates, what we actually need to remember to do is to add 2 to our x-coordinates. So if I just sketch over the graph of f of x, like so, I can then just simply shift it 2 units to the right, add 2 to the x-coordinates to get the final simplified answer. So what we need to do is just shift this all over 1, 2, like so. And so f of x minus 2 is this one I've done in blue. And that's all we need to say for that one. Question 19. A, B and C are 3 spheres. The volume of sphere A is 125 cubic centimetres and the volume of B is 27 cubic centimetres. We're then told the ratio of the radius of sphere B to the radius of sphere C is 1.2. Work out the ratio of surface area of A to the surface area of sphere C. All spheres are mathematically similar. So what this question is, without saying it, is linear area and volume ratios of 3 similar shapes, A, B and C. So let's do this in a table. So L for linear ratio, A for area ratio, V for volume ratios of sphere A, B and C. We're told the ratio of volumes of A and B is 125 to 27. So we can add this information in already. Now, if the volume ratio is 125.27, the volume ratio is the same as the linear ratios cubed. So to go from the volume ratio to the linear ratio, what we can do to both of these values is we can cube root them both. So if we cube root 125 and we cube root 27, we can therefore derive the linear ratio of sphere A to sphere B. The cube root of 125 is 5. If you cube root 27, you get 3. So that's our next step. The linear ratio of A to B is 5 to 3. But we're now told the linear ratio of sphere B to sphere C. Radius is a length, so this is a linear ratio. We're told the linear ratio of B to C is 1 to 2. So I could, if I wanted, write 1 here and 2 there. But that 1 doesn't match to the 3. So what can I do to the 1 to make it match to a 3? Well, what I could do is multiply it by 3. But if I multiply this 1 by 3, I need to do the same to the 2. So if I multiply both parts of this ratio by 3, I arrive at 3.6. I can now put this in to our table, like so. And because the 3 now matches with the 3 above it, I can then pull down the 5. So the ratio, linear ratio of A to B to C is 5 to 3 to 6. But the question isn't asking us for linear ratios, it's asking us for the surface area, the area ratio of A and the surface area of C. So we've got here for A and C, 5 and 6. To go from the linear ratio to the area ratio, we need to square these values in the linear ratios. So if we square these values, 5 squared becomes 25, 3 squared becomes 9, 6 squared becomes 36, like so. But we only need the ratio of A to the area of sphere. So we need to consider the 25 and the 36, like so. And therefore, the answer is just simply 25 to 36. And that ratio doesn't simplify down any further. So our final answer is just simply 25 to 36. Question 20. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8, and if it does not rain on one day, the probability that it will rain on the next day is 0.6. This weather forecaster says that there's a 70% chance that it will rain in the village on Monday. So let's start off with this. A 70% chance of rain is 0.7. If there's a 0.7% chance of rain, there's therefore a 0.3% chance, sorry, 0.3 chance I should say, but it doesn't rain. So chance of rain on Monday, 0.7. Chance of not raining is 0.3. So that's for Monday. We can now think about what happens on Tuesday. So for Tuesday, it could either rain or not rain if it rained on Monday, or if it didn't rain on Monday, again it could still rain or not rain. So if it rained on Monday, what's the chance of it raining again on Tuesday? Well, it says here if it rains on one day, the chance it will rain on the next day is 0.8. So this one here is a probability of 0.8. If there's a 0.8 chance of it raining, this one here must be 0.2. However, if it didn't rain on the day before, looking at this lower branch, the probability that it will rain the next day is 0.6. So if it didn't rain on Monday, the chance of it then raining on Tuesday will be 0.6. And if this one's 0.6, remember both branches need to add to 1. This must be 0.4. We then go again for the next day, Wednesday. So for Wednesday, let's imagine first of all it rained on Tuesday. If it rained on Tuesday, the chance of it raining again on Wednesday is 0.8, and not raining is 0.2. Let's now consider if it didn't rain on Tuesday. Like it says here, if it doesn't rain the day before, the chance it will rain the next day is 0.6. So if it didn't rain here, the chance of rain on Wednesday would be 0.6, and therefore not raining would be 0.4. Moving down to these lower branches, this one here, if it rained on the Tuesday, the chance of it raining on the Wednesday would be 0.8, chance of it not raining would be 0.2, and finally if it didn't rain on the Tuesday, the chance of it raining on Wednesday, because it didn't rain before, will be 0.6, and the chance of it not raining again would be 0.4. So as you can see here, because the question is asking us the chance it will rain on Wednesday, there's 1, 2, 3, 4 ways, 4 scenarios how it could rain on Wednesday. So the 4 scenarios, the first one, it could rain, rain, and rain again. It could be this branch here. It could rain, then rain, then rain. Or we could have it rains, then doesn't rain, and then rains. So it could rain, not rain, and then rain, which I've called in green. The third possibility is it could not rain, but then rain and rain again, which I've highlighted in blue. And the final scenario in purple, it could not rain on Tuesday, and then rain on Wednesday. So it could be this final branching here. To work out probabilities as we move along a probability tree, we multiply the numbers as we go along. And this is a fairly heinous calculation here, but this is the calculation we need to do. So let's do this together, step by step, carefully. So, rain, rain, and rain again is 0.7 multiplied by 0.8 multiplied by 0.8. Then we need to add 0.7 multiplied by 0.2 multiplied by 0.6. Then the final scenario, 0.3, sorry, the third scenario, times 0.6 times 0.8. And then finally, the purple, 0.3 multiplied by 0.4 multiplied by 0.6. We should get 187 over 250, and that's our final answer. Or, if you press SROD, as a decimal, we get 0.748. So those are the solutions to question 20. Question 21, the last question on the entire paper. So we're told the time period, t seconds, of a simple pendulum of length L centimetres is given by this formula here. This is a true formula, t equals 2 pi root L over g. Katie uses a simple pendulum in an experiment to find an estimate for the value of g. Here are her results. So L equals 52.0 correct to 3 significant figures. So let's just think about this for a moment. It's been rounded off to 52.0 correct to 3 significant figures. So we need to know an error interval for what L may have been before it was rounded. So let's imagine the times table of the third significant figure, 0.0. So imagine 52.1, 52.2, and so on. And as well on the lower side with 52.0 in the middle. So we'd have something like this. So before it was rounded, the value must have been closer to 52.0 than it was to 51.9 or 52.1. So it must have been on this side of this halfway line and to the left-hand side of this point here. So clearly, L must have been in between these two boundaries before it was rounded. So we split the difference in between 51.9 and 52.0. This lower boundary must be 51.95, and the same way, the upper bound is 52.05. So this is the error interval for L. So L is allowed to be 51.95, because if it were that exactly, it would have rounded up, but L has to be definitely less than 52.05, can be as close to it as you like without touching it, because if it were actually 52.05, technically that would have rounded up to 52.1. So that's why we have a difference of inequality symbol here. In the same way, T is 1.45 correct to 3 significant figures. So again, let's work out the error interval for T. So if you imagine the third significant figures times table, this 5, 1.45, 1.46, 1.47, and the same at the lower end of 1.45, you'd have some sort of system like this. You'd have a sequence of numbers like this, with 1.45 what it's been rounded to. So obviously, before the value was rounded, it must be to the right-hand side of this line, otherwise it would have gone to 1.44, and the value must be to the left-hand side of this defining line, otherwise it would have been closer to 1.46. So the value must have been in between these two boundaries here before it was rounded. So we split the difference again. This value would be 1.445, and this value here would be 1.455. And those give us the error interval for T. 1.445 inclusive all the way up to, but not including, 1.455. We now need a bit more space because we need to answer the question about the upper and lower bounds for the value of G, and G isn't even the subject of this equation. So let's make G the subject. What I'm going to suggest we do first of all is to square both sides of this. So if we square both sides to get rid of a square root, then what we get next is T squared. Then if we square 2, 2 squared is 4, square pi, that gives us pi squared. Then we've got the square root of L and G all squared, just gives us L over G. Now we want to have G as a subject, not as something divided by G, so what we could do is multiply both sides of this equation by G. So when we do that, on the left hand side, now we're going to have G T squared equals 4 pi squared times L. Then finally, to have G as a subject, we can divide both sides by capital T squared, and that gives us that G will be 4 pi squared L all over big T squared. But we need to work out the upper bound and lower bound for G. So when is G going to be maximum? Well, this is a fraction essentially. To make a fraction as big as possible, you put the stuff on the top as big as it possibly can be. 4 and pi are constants, but L does have an error interval, so we pick L max. So it's going to be 4 pi squared times L max all over, and to make a fraction as big as possible, we make the denominator as small as possible. So we're going to put the minimum value of T here. So we're going to go for T min all squared. So if we just substitute in that L max is 52.05 and that T min is 1.445. Oh, and by the way, it says clearly that use pi as being 3.142. I'll come back in a moment if you've used your calculator button for pi. Turns out the examiner's been nice enough and you can use either 3.142 or your calculator button, but because I'm very pedantic, I take things literally, so in my mind I think we need to use pi as 3.142 because that's an instruction the question's given us. Anyway though, just plugging this in, we've got 4 times pi, it says pi is 3.142, so I think do as it's told, times L max, which is 52.05. All of that is over T minimum squared, which is 1.445 squared. So now we just need to plug these numbers in carefully and record our result. So therefore Gmax, let's see, so we're going to have, let's move the calculator to one side for a moment. So it's going to be 4 multiplied by 3.142, because that's our version of pi we're using. Oh dear, I'm using pi squared, I should have said. Nearly an error there, I do apologise. 4.2 squared times 52.05 all over 1.445 all squared. We get 984.3677853. Doesn't say to round the answer, so we could just give them all if we want. 984.3677, and then it was 853. So that's one of the answers we need. We need Gmax, which we've just done. Now in the same way, we think what values of L and T would we use to calculate Gmin? Again, G essentially is a fraction. What we do is we pick the minimum values on the top of a fraction, so we go for L minimum, so it's going to be 4 pi squared times L min all over T max squared, because to make a fraction as small as possible, we make the denominator as big as we possibly can. So we're going to go for 4 times pi squared, so 4 times 3.142 squared times L min. L min is 51.95. Just going for that one here now for L min. And then T max at the bottom, the maximum value of T can be is 1.455. So that's what we put in for T max at the bottom, 1.455, all of that squared. So on the calculator we can just edit this actually. So pi is the same, 52.05, that needs to change though to 51.95, like so. And the 1.445 needs to become 1.455, so I can edit this like so. Press equals, and we get an answer of 969.018. And the rest of the digits, 0181643. So those are our two answers for the question. Gmax is 984 point so on and so on, so Gmax rather, and Gmin is 969.0181643. Now if you did use your calculator version of pi, you should have got these values instead. So Gmax, you should have got 984.11 and so on and so on, and Gmin, you should have got 968.76 and so on and so on. If you're wondering why these are different to mine, it's because 3.142 is actually pi rounded up slightly. 3.142 is an approximation. Your calculator will give pi more exactly, so that's why there's a slight difference in these answers. So be consistent, either use pi as 3.142 throughout, or use your calculator version of pi throughout. Don't mix and match them. Anyhow, that's the last question done, so I hope you found that question, or any others for that matter, useful. Please do subscribe and leave a comment in the comment section to show your appreciation, that's always nice. If not, I'll hopefully see you soon in class or around. So from me, Mr. Bailey, until next time, take care.